I would like to introduce our next keynote speaker that I'm also really looking forward to hearing, Associate Professor Richard Gorton. So Associate Professor Richard Gorton is a neuroscientist at the UQ, so the University of Queensland Centre for Clinical Research, where his team is focused on disease-modifying therapies for Parkinson's. So digging into neuroinflammation, the gut-brain connection, which we all know, how strong that is, and also drug repurposing. So ladies and gentlemen, please welcome Associate Professor Richard Gorton, who again, 30 minutes, and then we will allow 10 minutes for Q&A at the end as well. Richard Gorton.
Morning, everyone. First talk I'm giving where I've had music play, so it's amazing. I was told I could be a rebel and have the mic and walk around a little bit, which I like to do, rather than get stuck to the lectern. It's an honor to be here. It's incredible to be speaking after Clyde. I've heard Clyde speak at so many events, and it's always fascinating and inspiring to hear him speak. And we're very grateful for all the funding we've received from Shake It Up Australia. Our lab has been funded continuously since, I believe, 2016, Clyde, by Shake It Up and the Fox Foundation. So coming up to 8 years now with all the research that we're doing. So today we're here to talk about the gut microbiome and Parkinson's. It's always a popular topic wherever we present this. So this is work, again, initially funded by Shake It Up and Michael J. Fox Foundation. And we've then recently been able to get US Department of Defense funding on this as well. So we're based at the Translational Research Institute, this incredible building called TRI, down at the GABA, so right near where the cricket ground is. And it's on the Princess Alexandra Hospital. So the amazing thing with Translational Research Institute is we are based, this is where the labs and the industry partners are housed right here. And you can literally walk across from the lab and enter into the hospital where we can recruit patients, and a lot of our clinical trials and clinical studies run as well. So, and then we can bring those samples back with us through the lab and analyze it and process it. So for all of you who've participated in our research, thank you, and we're very grateful. And if any of you would like to participate in any of the microbiome research projects we are talking about today, our amazing team are right here. So we've got a booth as well, all over the room. And there's flyers that we can that you can participate on as well. So that's both for our current research and for our upcoming projects as well. So feel free to, there's some really cool prizes as well, I've been told, so definitely don't miss out on those. The amazing thing with TRI is, again, we moved here from UQ a couple of years ago, and this was primarily because this is one of the few environments in the world where you have the hospital, research university labs. There's actually 3 universities that operate here, and about 10 different industry partners, all of them located within walking distance of each other. This sort of an environment doesn't exist in too many places. And also we've got purpose-built research facilities here where you can take a human microbiome, human gut bugs, and put them into mice that are born without a microbiome. So you can study the Parkinson's microbiome in a mouse model, which there are only a few places in the world where you can do that, rather than study the mouse microbiome in a mouse model of Parkinson's. So so all of the work we're going to present today is translational research, or what we call translational research. And basically everything that we do is translational. So we study Parkinson's to understand the disease, but that's just the first step. The end game with everything that we do, all the research that we do, is to be able to diagnose Parkinson's earlier, but more importantly, to be able to find a treatment with whatever discoveries we make. So that's where we do preclinical research, so that's research in animal models, in cells, in mice, models of Parkinson's. Then we do clinical research, which is where we get the really valuable patient samples. So I'm sure many of you here have participated in our research at either UQ or TRI here. So that's where we validate what we find in our mouse models, in our microbiome studies, using human patient studies, and ensuring that everything that we're doing is based on human Parkinson's, not a mouse version of Parkinson's. So, and then all our drugs that are validated in the mice and human samples and all our drug targets move into clinical trials with one of our industry partners. So we have several industry partners that we work with. These are the current ones that we're working with in terms of drugs. So with Sanofi, we've got drugs that we can move into. They've got a blockbuster $1 billion drug for multiple sclerosis. With Fox and Shake It Up funding, we are now looking at taking that drug into Parkinson's, hopefully within the next year or two. With Epicentrics, we've got a cancer drug, a cancer care or chemoprotective drug. So basically, that's a drug that they've developed to protect people who undergo chemotherapy and radiation therapy for cancer. And what we found is this cancer protective drug has tremendous potential for protecting the brain as well. So again, with Fox Foundation funding and Shake It Up funding that we got in 2023, we've just wound down the animal studies portion of this program, and we're moving that into the clinic as well. So that's just a snapshot of what we do in terms of translational research overall. Most of our work, as always, has been started by seed funding from Shake It Up and Michael J. Fox Foundation or the Cure Parkinson's Trust in the UK. And then we go on to get the bigger funding from the US Department of Defense or other places, which allows us to do some of the more expensive and high-risk sort of research. So essentially everything that we do as a lab is translating research into treatments. So all of our research, all of our efforts, all of the discoveries we make, we ultimately want to take it into how can we harness this discovery or to either diagnose Parkinson's earlier, which means that gives us a much better chance of treating the disease, but also how can we take this treatment, whether it's a microbiome or a drug, and convert that into a treatment that would go into the clinic within 3 to 5 years is usually our timeline for most of our projects. So Parkinson's, as most of you know, it's one of the most highly prevalent and fastest growing neurological diseases globally. It is, the prevalence in Australia is pretty high, as with most Western countries. It's still not as high as the US or even Canada, but it's growing rapidly, as most of you know. Even in the 20 years that I've been studying and researching Parkinson's, I've seen, when I started my PhD 20 odd years ago, it wasn't as well known. I had to explain what Parkinson's was, but these days it seems like everybody knows somebody who has Parkinson's. So you can see this in real time, that Parkinson's is a rapidly growing and prevalent disease. And we think it's because of things like lifestyle and chemical exposures. And also their impacts on the microbiome is one of the theories that we have. So yeah, this is just bears out in this graph here. So this is from some of the data and in the very popular book from Ray Dorsey and Blas Boom and others who've raised the alarm bells with their book, The Parkinson's Plan, and other versions of it, and also the associated papers that they published, where you can see the prevalence of Parkinson's rising dramatically from 1976 to 8.4 people per 100,000. That's the death rate and also the prevalence rate here as well. So it's something that we need to tackle urgently and drive forward in terms of finding a cure. So these are just the Queensland numbers, very similar sort of situation. You have, I believe, about 15,000 people, and that's gone up from 2,000 almost a decade ago. And then the projections are looking quite dire as well. So in Australia, we know that someone's diagnosed with Parkinson's every 40 minutes or so. So these are just some of the biggest discoveries or key points in Parkinson's. You know, we've known about Parkinson's for almost 200 years. And even James Parkinson alluded to things like the gut microbiome and or the gut being important in the disease, but it's been 200 years and we still don't have treatments for it. So that's why our singular focus, just like what Clyde mentioned, is just in our lab, we just focus on research that can lead to treatments or lead to cures, and also lead to earlier diagnosis of Parkinson's, which then improves the chances of any treatments working. if you have biomarkers that can help diagnose people or allow us to target the right drug to the right person. So all of our research is focused in that space. So Parkinson's, as most of you know, is different for every person. It used to be just thought of as a disease that has loss of dopamine in the brain, which is how it's typically diagnosed when people go to their GP with a tremor and then they're sent to the neurologist. But it's so much more than that, as all of you know, and even in the questions that were that Clyde got, there's things like REM sleep behavior disorder, which occurs years to decades before you're even, people are diagnosed with Parkinson's. There's things like depression, constipation, and one thing you'd notice is all of these are what you call non-motor symptoms, and symptoms that don't have anything to do with tremor. And a lot of these things now, what we've found in the last 5 to 10 years, there's really strong links between depression and the gut, for example, with constipation and the gut as well. And these are things that show up 5, 10, 15 years before someone's diagnosed with Parkinson's or before they get a tremor, right? And then anxiety as well has very strong links to the gut microbiome. But what Parkinson's typically, the main focus for the last 200 years has been all of the motor symptoms and the associated loss of dopamine, which is the only treatment we have at the moment in terms of controlling the tremors and the motor symptoms with dopamine replacement. But Parkinson's also progresses. For many people, it progresses much faster. Some people are more fortunate and they have a slower progression or less of a decline, but the typical rate of progression is 9 to 15% based on the rating scales for most people. So there's a whole range of symptoms, as you can see. But what I want to emphasize here is this whole set of symptoms that shows up before you have the formal motor symptoms that everybody recognizes, the classic motor symptoms, is you have pretty much everything in this prodromal phase has a very strong link to the gut microbiome. And this just summarizes a whole bunch of treatments that are currently in development. This is put out by the Cure Parkinson's UK, disease-modifying drugs. So it's not for lack of trying as researchers. We've not had any new drugs approved since 2018 in terms of which can slow or stop disease progression, or even new classes of medications from the FDA. But you can see here it's not because we're not trying. There's nearly 136 drug trials that are running globally. 76 of these are intended, what we call disease-modifying trials that are looking to slow or stop the progression. But as Clyde said, Parkinson's is a complex, it's a beast. It involves not just the brain, it involves the gut, the blood, the immune system. There's a whole range of complexities associated with it. And there's still very little that we understand in terms of how Parkinson's starts, what causes it to progress and such. Chemical exposures is what most of us now recognize as one of the early initiators of Parkinson's. Head trauma is another one of those. So with Parkinson's, with chemicals, there's pesticides that have some of the strongest risks for Parkinson's. So things like rotenone, paraquat, things that we used to take for granted in terms of spraying crops over 10, 20, 30 years ago. But it's also things that we don't really recognize in our day-to-day exposures. You don't need to be a farmer to be exposed to some of these chemicals. But it's not any sort of chemical that's linked to Parkinson's. There's very specific types of chemicals, solvents, pesticides, heavy metals that have the strongest links. And that's sort of what's outlined here. You see things like PCBs and all of PFAS, bisphenols, phthalates, plastics. Those things don't have a strong risk for Parkinson's, but things like pesticides, heavy metals, organic solvents, those increase your risk for Parkinson's, especially if the exposure occurs decades or years earlier. So, and we see this often in people who participate in our research as well. So one of the recent studies that's come out in terms of golf courses and the risk of Parkinson's, this was published in JAMA, the American Journal of Medicine, and they looked at whether proximity to golf courses can increase a person's risk for Parkinson's. And this came out from Brittany Krasanovsky's lab, and Ray Dorsey and others were involved in this as well. And this was just a few months ago, so it is quite controversial. But also what you'd see with this study is the numbers are quite large. So they have fantastic data in the US to back up studies like this, where there are people, there are large numbers of people people who participated who were part of this data set. So it's not a small data set by any means. But what that highlights is, again, it needs to be replicated and reproduced, and other studies are being done on this as well to follow up. But what they believe is proximity to golf courses is a risk factor because of the chemical exposures and what they spray on these golf courses to make them look amazing in the US, and all of the runoff from the pesticides and chemicals that occurs there. So some fascinating links, again, to the gut microbiome. And this leads me into some of the other work we're doing here in our research in terms of the toxic exposures research program. So this is work funded by the US Department of Defense. We are looking at, this is work running at the University of Queensland and QUT and TRI. And we are looking at developing countermeasures for people who are exposed to chemicals. And this was work funded initially by Shake It Up and Michael J. Fox, and then we went on to get Department of Defense funding. And the US Department of Defense, they're one of the largest funding agencies globally for research on chemicals and pesticide exposures. And so some of the work we're doing here is to develop new treatments for people exposed to chemicals in either occupational settings or in military settings, where you have a lot of you're commonly exposed to chemicals that are linked to Parkinson's. So this is just some of the work that we have on there. We're developing a drug with this company called Epicentrix, and this is a cancer chemoprotective drug that I mentioned earlier. So it has 3 mechanisms of action. I won't bore you with the science, but essentially what we've done so far is we've taken this drug with funding from Shake It Up, Fox Foundation, and others, and we've been able to test it. It's already been in humans for protecting against chemotherapy and radiation therapy. But we've been able to test this now in 3 animal models of Parkinson's and found out that the drug works excellently well across all of them. And we've done large animal studies here as well. Each point you see here is one animal in a study. So you can see we've tested it in several animal models of Parkinson's. And this was presented at the Fox Foundation Therapeutics Conference last month in New York. And we are now awaiting funding to take this drug into the clinic. And if we are successful, it'll be co-funded by Shake It Up as well. And we would have clinical trial sites here in Australia, hopefully in the next year or 2, if all goes to plan. So that brings me to the gut microbiome. And the reason the chemical exposures was discussed before this is because we think the chemical exposures is a risk factor for the microbiome, and it's one that we don't often recognize. We always think of the gut microbiome as being impacted by things like antibiotics and your diet, but we often don't make the link between exposure to chemicals in drinking water or other places directly impacting your microbiome, similar to how antibiotics or other sort of drugs might impact it. So what we've got here, and it's a bit hard to see because I've got my own video there that's blocking it. I'm not sure if that could be removed there. Oh, thank you. Yeah, so what we know from, in terms of the complexity of the microbiome, just to give you an idea, the human genome was sequenced in the early 2000s, and we know that we have about 22,000 genes that are active as humans. And to give you a comparison, the gut microbiome has nearly 8 million genes that we know of at the moment. Oops. And so so the human genes that we have and our genes and proteins that we make pales in comparison to what we have in the gut microbiome, which is close to 8 million that we know of. And that's just from the bacteria. There's also the fungi, the viruses in the gut, and other microbes that we don't even know and understand yet, and even viruses that populate the gut. So essentially, our microbial genes outnumber the human genes by almost 100 to 1. So it's a very complex ecosystem in our guts and even on our skin and other places. So the gut microbiome, essentially, we are born with a gut microbiome, and then it develops with us. It's impacted by our environment, our genetics, our diet. So there's a whole range of factors that the microbes make. But in a healthy gut, essentially, your gut microbiome supports your brain health. It supports development of the immune system. It trains your immune system to not attack its own host and trigger an autoimmune disease. So, and it maintains a healthy gut barrier and also a healthy gut-brain barrier now, as we know from recent research. So the gut microbes perform a lot of housekeeping things that we take for granted when we're awake and when we're asleep. And it's important for healthy aging and healthy immune system development as well. And what we know now is Parkinson's, there's dysregulation of the immune system. It happens years to decades before someone is diagnosed with loss of dopamine. So everything now that we understand about Parkinson's in hindsight leads back to dysregulation of the gut in many ways. And that evidence is just mounting so far. And I feel that's where there will be a lot of breakthroughs in terms of treatments in the next decade or so. And that's why we're focused on the gut microbiome as much as we do on the brain at the moment. So there's still a lot that we don't know about the gut, but ironically, even in James Parkinson's original essay, The Shaking Palsy, where he described Parkinson's for the first time almost 200 years ago, he made a note that a disordered state of the stomach and bowels, as they say back in the day, in his patients, and he speculated that the dysregulation of the stomach and the bowels could be one of the early signs or triggers of Parkinson's, or that it could have something to do with Parkinson's. But of course, as researchers, we tended to focus on the brain entirely for almost 200 years, and we've not looked at the gut probably for the last 15 to 20 years and taken it seriously. But James Parkinson sort of knew something back then. And if we had listened to him or we had taken this a bit more seriously, perhaps we'd have a bit more progress in terms of what we know about the human microbiome. But also in terms of studying the human microbiome, given the complexity of studying the bacteria in the gut and such a complex ecosystem where you have millions and billions of bugs that populate our gut, we've simply not had the technology to study it so far. And part of the reason we haven't made a lot of progress with the gut microbiome is there is so much complexity and data and noise there that separating the microbial DNA from the human DNA is a real challenge. And so there's real technological challenges there that still need to be overcome. And I know there was a question from an IT person here, so if you do have ideas on what we could do there, we'd love to partner with you in whatever in ways that you could help us with any of this. Yep, so the gut-brain axis, it's a complex conversation. There is a lot that happens in the gut. The gut talks to the brain, and the brain talks to the gut. There's metabolites, there's neurotransmitters, there's hormones made by your gut bacteria that we've previously not had any links in terms of how they trigger Parkinson's. So the gut can trigger, there's surprisingly lots of things that we associated with mood and depression that's made by the gut. So you'd see here, this just summarizes some of the neurotransmitters that the gut bacteria can make. So oxytocin, which is commonly called the love hormone, that's made by the gut. GABA is made by gut bacteria as well and communicates with the brain via the vagus nerve. Neuroprotective factors like BDNF, which similar to nerve growth factor, is a protective factor for neurons in the brain. That's made by specific bacteria in the gut as well. And the gut communicates with the brain via the vagus nerve, which is sort of the highway of gut-brain communication. So we found this in animals now. When you replace these bacteria, when you put in the good bacteria, you can improve their mood and anxiety. When you destroy the good bacteria using antibiotics in mice, for example, you can affect their mood and their social behavior and depression phenotypes and things. So those links are now really strong, and a lot of that's come from autism research as well, which has a very strong link to the gut microbiome. So obviously it's a complicated conversation. It's not just the brain communicating with the gut, it's the gut communicating with the brain as well. And we know now that Parkinson's, there's a theories that there is brain-first versions of Parkinson's and also gut-first versions of Parkinson's. We don't really have an understanding yet of which occurs first, so it's possible that both are possible, that Parkinson's could start in the brain in some people, it could start in the gut in some people. But there's definitely a lot of evidence for a gut first mechanism of Parkinson's in at least some people, if not many people. So yeah, in terms of does the gut microbiome play a role in Parkinson's, this has been a long-standing question. This was a summary from Nature a few years ago, which had what were the 4 big questions in Parkinson's in the field at the time. And the gut microbiome is definitely one of them. So what we see is gut symptoms are an early feature of Parkinson's disease. So as we saw earlier, things like depression, constipation, all of that is linked to the gut microbiome directly. Synuclein aggregates, so the Lewy body aggregates that we find in people with Parkinson's, you can find them in the nerve cells of the gut as well. And then markers of gut inflammation are also increased in Parkinson's. So it's no longer just brain inflammation and inflammation in the blood, which is what we used to study and focus on for the last 10 or 20 years. So there's also markers of gut inflammation that are really important and observed. So yeah, understanding the gut microbiome could lead us to new treatments and new ways to study and treat Parkinson's. So I won't bore you too much with the science. I'll just give you the summaries here. So it was controversial, obviously, to understand whether the gut microbiome plays a role in Parkinson's. So what it took is essentially research which showed that across all the studies done all over the world, no matter where you are in the world, no matter what your diet is, you still have a signature related to Parkinson's and the gut microbiome. So there's unique sets of bacteria that are either increased or decreased in people with Parkinson's. So that's what we know now. So what this all means, we're not sure yet. But what we know for sure is that microbiome changes are linked to your genetics, but it's also linked to Parkinson's itself. So if you take a healthy person who is 65 and a person with Parkinson's who is 65, even if they live in the same household, they have the same diet, the person with Parkinson's has a unique change in their gut microbiome. And so that's what we don't really know what the cause or the consequence of that is. We're trying to understand that, and that's where everyone participating or donating a microbiome sample in our research project makes a huge difference, because it helps us understand that. And the more people we can study, the more we can answer that question and then move on from understanding what is it that's different about the Parkinson's microbiome, and then look at how we can target it, as I'll show you here with some of our slides. So we know that the microbiome is different in people with Parkinson's, but that also means there's different chemicals and other protective agents coming out of the microbiome. So how the microbiome metabolizes the food we eat is different in people with Parkinson's. So that's sort of what's summarized here. Amino acid and nucleotide metabolism is altered in people with Parkinson's in their gut microbiome. So what does it all mean? We don't know yet. All we know is that there are very specific changes linked to Parkinson's and the microbiome that's associated with aging. So similar to this here, so this is the beneficial bacteria, and this is a bacteria that suppress and reduce inflammation in people. So you'd see there, with people who are healthy, you have an abundance of this sort of bacteria in the gut. But as people who start to get constipation early in life, or chronic constipation, those beneficial bacteria tend to reduce. And people who are diagnosed with Parkinson's as well, so you still have a loss of these beneficial anti-inflammatory bacteria that occurs. So, and this is a theme across studies in Parkinson's done in the US, in Europe, in China and other places. So diet plays a role, but you can still see these overall themes in terms of the gut microbiome in Parkinson's. So that's just a little bit more summary of what happens there. Depending on people who have motor dominant or tremor dominant Parkinson's and non-motor Parkinson's, they tend to have slightly different signatures. And also the microbiome tends to correlate with a disease progression as well. So as someone progresses with their Parkinson's, they tend to have a different microbiome signature. But again, we know it's different, but we don't know what that does. So another example of how important the microbiome is, a few years ago in the journal Science, there was discoveries that the bacteria, some people had specific strains of these bacteria that would completely be able to chew up the dopamine or levodopa replacement treatments that people were taking. And that was associated with side effects like dyskinesia that occurs in people. So for almost 100 years, we didn't know why people who had dopamine replacement, either natural dopamine replacement or the drugs, had some side effects. So this was just more evidence of that. So if you put the microbiome from a Parkinson's patient into a mouse, you worsen the symptoms or you can accelerate the disease. So that was also a huge amount of evidence that showed the gut microbiome is important in Parkinson's, and one of the key studies that helped us provide direct evidence that the microbiome can drive the disease progression. So basically, to summarize it all, what we find in terms of the gut microbiome in Parkinson's, it's different. We know there's different microbes in the gut of a person with Parkinson's. We know that they produce different range of substances from a healthy person of the same age, and that's important. And what we understand so far is what that means is you have less intestinal barrier permeability in terms of the gut. You have more inflammation signature in terms of the gut microbiome. And you have more blood-brain barrier permeability as well, which all of that's linked to disease progression by several different mechanisms. There's a lot of science there for people who are interested. I can share my slides as well if needed, and there's a good summary here for those who are keen to read a bit more on that. So chemical exposures are linked to gut microbiome dysfunction. We know that now, and there's, again, a whole bunch of evidence that supports that. I won't go into it in too much detail other than saying the timing of the microbiome changes relative to PD onset. We don't know where that occurs yet, but we know that that does occur. So what we're doing in the research, for those of you who have participated really quickly in the work in the studies we're doing at TRI and QUT, we are looking at targeting this particular microbiome metabolite called TMAO that's linked to Parkinson's disease progression, and we are looking to block that with drugs. So essentially, what the data has shown so far is that if you're a person with Parkinson's, you have elevated amounts of this compound called trimethylamine oxide, TMAO, that's produced by the gut only, and it's not produced by humans, it's produced only by bacteria. And if you're a person with Parkinson's, you progress faster if you have elevated levels of this. So we found this in our Australian Parkinson's patients as well that we've done at UQ and QUT. And what we're trying to do now is, yes, we know that it's elevated, it's harmful, it drives disease progression. So what we're trying to do with this work is seeing if we can block it using drugs. So we have a few compounds that we're testing in proof of concept. So we take the human microbiomes, put them into animals, and we test them with drugs to see if we can slow down the bacteria that produces this compound, the enzymes that produce it, and then if that could be a protective, or if that could slow down the disease progression. So why this is really important is the first time we're testing a drug that targets bacteria and not the human immune cells or trying to protect the brain, but we're targeting the gut directly. So this is some of the other approaches that are being tried. This is fecal microbiome transplants. There's, these were not successful in the first couple of trials that were done, but there was a recent targeted fecal microbiome transplant study. This is a common medical procedure. It's easy to implement. It's low cost. So this was done in Europe, and then they found that people had lasting improvements in motor symptoms and some non-motor symptoms as well. So there are several other treatments on the horizon. Diets, prebiotics, probiotics, fecal microbiome transplants, and drugs are probably the most interesting and promising. There are engineered prebiotics and probiotics that we're looking at as well. So I'll skip through what we can do until, we don't fully understand what the microbiome does. There's a long way to go, but what you can do until then. Diet and exercise has a profound impact on the microbiome. Your GPs and neurologists probably tell you this. So there's a lot we can do there. You can participate in research and help us understand the gut microbiome even better. And this, I'll close by just leaving this up here. This is the National Parkinson's Action Plan. Shake It Up and other national organizations have come together, campaigned the federal government for better access to treatment, better research and things. So there's a lot of information on this on our booth as well, so for people who are interested. We are hoping to make a 10-year action plan to revolutionize how we treat Parkinson's, how we care for people with Parkinson's, and how Parkinson's research proceeds as well. So there's lots of this on our table and booth, and I'll wrap up with this here, and thank you very much for your attention.
Test 2.
So we have time for a couple of questions too, if anyone would like to ask a question. But just while we are getting microphones to the people that have questions, could I ask one, Professor Gorton? What is the one simple thing we could all do every morning to kickstart our day to help our gut microbiome?
Oh, that's a good one. I would suggest a smoothie that's got prebiotic and probiotic fibers. in it. That's a good way to start. Yogurt that's homemade, not bought in the store, because the store, once you've got to pasteurize it, and that kills the gut bacteria.
Oh.
So things like that could be done. Homemade fermented food's a good idea if you can stomach that in the morning. But otherwise, a smoothie is a good one. That seems to be palatable. You could put various different fibers that feed your gut. One thing that people could do is you could get your gut microbiome sequenced. I know a lot of people I've spoken to participated in our trials. You could buy a kit and get your microbiome sequence. It costs about $200 to $300, but I will tell you what's increased, what's decreased in your gut microbiome, and if you're able to do that. We still don't know what those changes mean, as you see in the research, but what that could mean is some of those are beneficial. You could try and increase your beneficial bacteria if you know which ones are lost, and there's ways to target bacteria by specific types of fruit and things, so yeah.
Alrighty. Oh, question, please.
Yes. Do you have an opinion on the efficacy of stimulating the gut microbiome with the Symbix deep light therapy device?
Yes, we don't understand how that works yet. We know that the red light therapy's got a lot of beneficial effects on the mitochondria. So I, like many other researchers, thought the beneficial effect was by the mitochondria, because red light therapy stimulates mitochondria in your skin. But there seems to be a fascinating link occurring with the gut microbiome, because I've met with the people who use that device, and we're trying to actually start a collaboration with them to look at in the gut microbiome of animals whether we can do something. So yeah, that's on our radar to look at. We just don't have the funding for it yet, because red light therapy is not something that it's easy to get funding for, but I've heard really positive things from people I've spoken to who've used it, who've used the Symbix device.
Another question in the centre of the room.
Yes, Doctor, in your introduction you mentioned head trauma. I have had a brain tumour and now have Parkinson's, wondering if there's any connection.
There's not a direct link to brain tumors. There's head injuries and concussions and things like that that have a higher risk for Parkinson's. So Muhammad Ali is a good example of that. But I don't think brain tumors themselves have a direct link with Parkinson's. Fascinatingly, there's some research in the early 2000s which has showed people with Parkinson's have a lower risk for some types of cancers as well. So we still don't understand that, but now we know the gut microbiome could be a link between that sort of work as well.
Another question just to the side.
It's on. Okay, Dr. Gorton, thank you very much. It's the first time I've been to one of these meetings where you're actually suggesting a link between chemicals and Parkinson's. I should say that I'm an occupational cancer specialist with the ILO WHO for many, many years, and we link chemicals with cancers and occupational exposure. Are you aware of any meaningful epidemiological studies between chemical exposure and Parkinson's? Because to follow on from that, you were talking about the American military, all right? Well, Agent Orange, we know darn well, caused so many cancers to the exposure of soldiers underneath. Was any study done to those soldiers in terms of Parkinson's numbers, anything like that? Thank you.
The US Department of Defense has a lot of internal research. They don't always publish it because it's sensitive to the military, but one of the reasons they deploy the Parkinson's research program is one of their largest funded programs in the US Department of Defense. So they do that because there is a very strong undeniable link now that even they recognize on all of their documents, where even in their internal numbers, people in military service have a much higher risk of Parkinson's. In certain occupations in the US, even some states have legislation now to protect firefighters, for example, if they
pesticide exposure, you know, the ILO, WHO, IARC put out chemicals and they are carcinogens or potential carcinogens. Do you envisage a stage where those organizations will put down potential Parkinson's or neurotoxic sort of exposures?
I do think for certain classes of chemicals, definitely we're heading in that direction. So the ones that are high risk right now, things like paraquat and solvents like TCA, all of those. I don't think it'll be broad chemical exposures, like exposure to phthalate, for example, which messes up our hormones and stuff. They're, endocrine disruptors. Those things don't have risk, increase your risk of Parkinson's. But things like heavy metals, welding, those sorts of things have a much higher risk. So yeah, I'd love to chat with you more at our booth or any other places. Yeah, yeah.
Where is your booth?
It's just outside. It's the Translational Neuroscience Lab. So yeah, just find out our amazing team there.
Okay, so TRI, and anyone else who we haven't been able to get to with questions, please just forward them through to the park, and they can be forwarded, to Clyde or to yourself as well. So thank you again so very much, Professor Richard Gorton. It was amazing.
Thank you very much.